Download this code from codegive.com, link in the description below. Visual Studio Fatal Error C1083, cannot open include file, a comprehensive guide. The fatal error C1083, cannot open include file, no such file or directory is a common stumbling block for C++ developers in Visual Studio. It signifies that the compiler is unable to locate a header file specified in your include directive. This error can arise from several causes, and understanding these reasons and their solutions is crucial for smooth C++ development. This tutorial will walk you through the potential causes, diagnostic steps, and solutions to resolve this error, along with practical code examples. Understanding the root causes *. The core issue is simple: the compiler doesn't know where to find the header file you're asking it to include. However, the reasons why it can't find it are more nuanced. Here's a breakdown of common culprits. 1. Typographical errors *. The most basic, and often overlooked, cause is a simple typo in the header file name within your include directive. It's surprising how easily a single misspelled character can trip up the compiler. 2. Incorrect include path *. The compiler searches for header files in a predefined list of directories. If the header file's location isn't included in this list, the include path, the compiler won't find it. This is the most frequent cause. 3. Missing or incorrect library installation *. You might be trying to include a header file that belongs to an external library that hasn't been properly installed or linked with your project. This is common when using libraries like Boost, SDL, or OpenGL. 4. Relative paths and project structure *. If you're using relative paths in your include statements, example include my_headers / my_file.h, ensure that the relative path is correct relative to the current source file being compiled. An incorrect project structure can easily lead to broken relative paths. 5. Platform configuration mismatch, x86 versus x64. If you're using precompiled libraries or header files specifically built for a certain architecture, example x86 or x64, your project's target platform must match the library's architecture. Mixing 32-bit and 64-bit code can lead to this error. 6. Precompiled headers, PCH, issues *. If you're using precompiled headers and the include paths are not set correctly, especially for headers within the PCH, the compiler can fail to find the required files. 7. Case sensitivity. Sometimes while Windows file systems are generally case insensitive, some build environments or external tools might be case sensitive. Ensure that the case of the header file name in the include directive matches the actual file name on disk, especially when working with cross-platform projects. 8. Permissions issues *. In rare cases, the compiler might not have the necessary permissions to access the directory containing the header file. This is more likely to occur when working with network drives or restricted directories. 2. Diagnosing the error ***. When you encounter the C1083 error, follow these steps to pinpoint the cause. 1. Carefully examine the error message **. The error message itself provides valuable information. Pay close attention to the exact file name being reported **. This helps you identify the problematic header file. The no such file or directory part **. This confirms that the compiler can't find the file in its search paths. The source file where the include directive is located *. Knowing which source file is triggering the error is crucial. 2. Check for typos *. Double check the header file name in the include directive for any typos, including capitalization errors. It's easy to miss a single incorrect character. 3. Verify the file's existence *. Confirm that the header file actually exists at the location you expect it to be. Use Windows Explorer, or the command line, to navigate to the directory and verify the file name. 4. Inspect include paths *. Examine the include paths configured in your Visual Studio project. You can do this as follows. Project properties *. Right-click on your project in the Solution Explorer and select Properties. C/C++-general-additional include directories *. This setting lists the directories where the compiler searches for header files. Make sure the path containing the header file is listed here. If it's a relative path, ensure it's relative to the project file or a common parent directory. 5. Consider relative versus absolute paths *. Are you using relative or absolute paths in your include directives? Relative paths can break if the project structure changes or if you're compiling individual files from different locations. Using absolute paths can make your project less portable. 6. Check library installation *. If the header file belongs to an external library, example Boost, SDL, verify that the library is correctly installed and that its include directory is added to the project's include paths. 7. Verify platform configuration *. Ensure that your project's platform configuration, x86, x64, matches the architecture of any precompiled libraries you're using. If you're using 32-bit libraries, your project should be configured for x86, and vice versa. 8. Investigate precompiled headers *. If you're using precompiled headers, check the settings related to them in the project properties. Incorrect PCH settings can sometimes cause include path issues. 3. Solutions with code examples ***. Let's illustrate the solutions with code examples and how to apply them in Visual Studio. Scenario 1, missing header file, typo/incorrect path. Problem you have a header file named my_utility.h in the directory include, but your code has a typo or an incorrect path. Solution 1, correct the typo *. The most straightforward fix is to correct the typo in the include directive. Solution 2, add the include path *. If the file exists but the path is incorrect, add the include directory to the project's include paths. 1. Project properties *. Right-click on your project in the Solution Explorer and select Properties. 2. C/C++-general-additional include directories *. 3. Add the path to the include directory *. If the include directory is directly under your project directory, you can use a relative path like $project dir, include. If it's elsewhere, use the full absolute path. Scenario 2, external library, example Boost. Problem you're using Boost libraries, but the Boost include directory isn't configured in your project. Solution 1. Install Boost first, ensure that Boost is properly installed on your system. You can download it from the official Boost website, www.boost.org. 2. Configure include paths *. Add the Boost include directory to the project's include paths. The Boost include directory typically looks like c \1_83_0, the exact version number will vary. Follow the same steps as in Scenario 1, adding the Boost include directory to additional include directories. 3. Configure library paths. If needed for Boost libraries that have precompiled parts, some Boost libraries require you to link against precompiled libraries. If you get linker errors related to Boost after adding the include paths, you'll need to configure the library paths as well. Project properties linker general additional library directories add the directory containing the Boost library files, usually under stage/lib within the Boost installation directory. Project properties linker input additional dependencies specify the names of the Boost library files to link against. The names will vary depending on the library and compiler, but they usually have the form libhost_**. Scenario 3, Relative Paths and Project Structure. Problem You're using relative paths in your include directives, but the project structure or compilation context makes the relative paths incorrect. Solution 1. Verify relative paths. Carefully examine the relative paths in your include directives. Make sure they're correct relative to the location of the source file that contains the include directive. 2. Adjust project structure. If necessary, if the project structure is causing the problem, consider reorganizing the directories to make the relative paths more consistent. 3. Use project relative paths in the project properties, C/C++-general-additional include directories, instead of using absolute paths or relative paths based on the current directory. Define paths relative to the project directory using the $project_dir macro. This makes your project more portable. For the example above, you could add $project_dir source to the include paths, and then use include util/my_utility.h in main.cpp and include util/my_utility.h in my_utility.cpp. Scenario 4, Platform Mismatch, x86 versus x64. Problem You're using a 32-bit library in a 64-bit project, or vice versa. This can lead to c1083 errors when trying to include header files that are specific to the library's architecture. Solution 1. Match platform configurations. Ensure that your project's platform configuration, x86 or x64, matches the architecture of the libraries you're using. 2. Download or build for correct architecture. Obtain or build the libraries for the correct architecture, either x86 or x64, that matches your project. 3. Configure library paths correctly. If you have separate library builds for x86 and x64, make sure you're linking against the correct library files based on the platform configuration. You can use conditional configurations in the project properties to specify different library paths for different platforms. Scenario 5, Precompiled Headers, PCH, Issues. Problem Incorrectly configured precompiled header settings. If headers are intended to be included in the PCH but their include paths are not correctly configured, the compiler won't find them. Solution 1. Check the precompiled header property in your project properties, C/C++-precompiled headers. Verify that the precompiled header setting is set to create or use appropriately. 2. Verify precompiled header file. Make sure the precompiled header file setting is correct, usually staffs.h. 3. Check use precompiled header in the staffs.cpp, or equivalent, file. Ensure that you include staffs.h as the very first line. 4. Ensure include paths are correct for PCH headers. If any of the headers included in staffs.h are causing c1083 errors, make sure that the correct include paths are configured in the project properties, C/C++-general-additional include directories. These paths must be accessible when the compiler is processing staffs.cpp to create the precompiled header. Code example, precompiled headers. Scenario 6, Case sensitivity, less common on Windows. Problem The header file name in the include directive has incorrect capitalization. Solution correct the capitalization in the include directive to match the actual file name on disk. Debugging tips clean and rebuild sometimes, stale build artifacts can cause issues. Try cleaning your solution, build-clean solution, and then rebuilding, build-rebuild solution. Asterisk verify configuration asterisk double check that you're building the correct configuration, debug or release, and platform, x86 or x64. Asterisk use debugger asterisk if the error persists, try using the Visual Studio debugger to step through your code and examine the include paths and variables involved. Asterisk simplify the problem asterisk if you're unsure which header file is causing the issue, try commenting out include directives one by one to isolate the problematic file. Asterisk search online asterisk the c1083 error is common, and there are many discussions and solutions available on online forums and Stack Overflow. Search for the error message along with the specific header file name to find relevant solutions. Best practices asterisk. Asterisk use consistent include paths asterisk adopt a consistent approach to managing include paths in your project. Use relative paths based on the project directory or absolute paths for well-known libraries. Asterisk organize your project asterisk maintain a well-organized project structure to make relative paths easier to manage. Asterisk document dependencies asterisk keep a record of the external libraries your project depends on and their installation instructions. Asterisk avoid hard-coded paths asterisk try to avoid hard-coding absolute paths in your include directives. Use project relative paths or environment variables instead. Asterisk regularly test your builds asterisk test your builds frequently to catch include path issues early. Asterisk use a package manager, example vcpkg, NuGet consider using a package manager to manage your dependencies. This can simplify the process of installing and configuring external libraries and automatically handles include and library paths. By carefully following these steps and understanding the potential causes, you can effectively diagnose and resolve the fatal error c1083, cannot open include file and keep your C++ development process running smoothly. Remember to always double-check your code, project settings, and library installations. Good luck.